Okay, for given points A, B, and C, D on a graph, the fundamental triangle is the triangle with vertical and horizontal sides and vertices at the 2 points. Now we could have drawn it up here too. We would have had a horizontal and a vertical side, and the vertices still would have been here. Doesn't matter which side we draw it. Now we label a rise and a run, and we also want to label a direction. So if we move from here to here, and of course we could be moving from here to here, there are 2 ways to get from this point to this. We go through this way or this way. Okay. Now if we go along the legs of the triangle, then the rise is going to be what? Well, we start at B and we end up at D. So it turns out that that's D minus B. Our displacement along this side will be D minus B. That'll be the rise. The run will be, well, from A to C, the displacement is C minus A. Now we want to label the hypotenuse, the length of the hypotenuse. And we also want to label a slope. Well, we could say, okay, well, let's see, slope equals the rise, D minus B, divided by the run. Rise is D minus B, the run is C minus A. Went outside my box a little bit there, but I think that's legible. That's the rise divided by the run. And that's what we think of when we think of slope. That's also the rate of change. We'll come back to that idea. Okay, the length of the hypotenuse and I'll abbreviate hypotenuse, is what? It's the square root of the sum of the squares of the legs. This leg is D minus B. This leg is C minus A. Now, of course, if I gave you 2 numbers, you'd be able to do the subtraction, so you just have a number here to square and a number here to square. And you'd have just a number here for the rise and a number here for the run, and you'd be able to divide them and express the slope as a single number. The midpoint of the hypotenuse has a characteristic that, well, this right triangle here and this right triangle here have the same base angle, because these are 2 horizontal sides intersecting the same line. They have to make the same angle. These are 2 parallel lines intersecting this line. So you have 2 parallel lines and a transversal. So these angles are the same, so that these triangles, if this is the midpoint of the hypotenuse, the hypotenuse of this smaller triangle has got to be equal then to the hypotenuse of the larger one, each being half the length of the hypotenuse here. This means that this side has to be the same as this side, and this side has to be the same as this side, so that the x-coordinate of this point is halfway between the x-coordinates of this point and this point, and so is the y-coordinate. So for the midpoint, didn't leave myself a lot of room to write here. I'll just write it this way. Now, halfway between the x-coordinates then is halfway between A and C, and halfway between two numbers is what you get if you average the two numbers. So that's going to be A plus C over 2. The y-coordinate is going to be halfway between B and C. Well, that's going to, B and D, sorry. That's going to be B plus D over 2. So, there's an argument, a simple geometric argument that I hope everybody understands. And simply the idea that if you average A and B, you do that by adding A and B and dividing by 2, you get the number that's halfway between. That would be the x-coordinate. Halfway between the x equals A and the x equals C is x equals A plus C over 2, and that's the x-coordinate of the midpoint. And then the same argument with the y-coordinate.